Okay, talking about 7.3 here, tests for parallelograms on page 421. Okay, so if a quadrilateral has each pair of opposite sides parallel, it's a parallelogram by definition. But that's not the only way to prove that you have a parallelogram. Okay, so there's other ways to do that. So you can prove a few things. So by definition, you can prove that if a quadrilateral, let's start that over. So you can prove that if a quadrilateral has each pair of opposite sides parallel, then it's a parallelogram. Okay, so there's one of your reasons. And then you have these other ones that are down here. So if, and essentially it's all of the properties, if both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. Make sure you are very careful with how you write this because it has to be both pairs. If all you say is if opposite sides of a quadrilateral are congruent, that's not enough information. Okay, so both pairs of opposite sides of a quadrilateral are congruent, then it's a parallelogram. If both pairs of opposite angles of a quadrilateral are congruent, then it's a parallelogram. If the diagonals of a quadrilateral bisect each other, so it's not just that one bisects the other, then the quadrilateral is a parallelogram. And if one pair of opposite sides of a quadrilateral is both parallel and congruent, then the quadrilateral is a parallelogram. So those are all the ways that you can prove that, and we're going to go through a few of those here. Okay, so the mosaic pattern of the floor is made up of different tiles. Find the values of x and y so that the tile is a parallelogram. So we want this to be a parallelogram, therefore we want the properties to apply. And in this case, it gives you lengths of sides, so we want opposite sides to be congruent. So we want 3x plus 4 equal to 5x minus 2, and we want 4y minus 9 equal to 2y plus 5. So you can solve these two equations here. Subtract 3x, you're going to get 2x. Add 2, you're going to get 6. Divide by 2, you're going to get x equal to 3. And then here, subtract the 2y, you get 2y. Add the 9, you get 14. Divide by 2, you get your y equal to 7. So you've got your x and your y there. Select the theorem you can use to find the values of x and y. So what theorem did we use? We said that if both pairs of opposite sides are congruent, then it's a parallelogram, and that's what we used there, okay? Now, justifying, we're going to get back into some of these justifications and what we can do with those. So there's an example in your book of how this kind of goes with midpoints. So they calculate a midpoint, calculate another midpoint. Since the midpoints are not the same, the quadrilaterals, the diagonals don't bisect each other, and therefore it's not a parallelogram. So for this one, I'm going to go through it with all of the different ways just because I want to show you guys all of the different options that you have here, okay? So if I was going to justify this with midpoint formula, you're not doing the midpoints of the sides, you're doing the midpoints of the diagonals because your goal is to prove that the midpoint of AC and the midpoint of DB intersect at the same place so that you have those congruent, okay? So that's what you are trying to prove in this case. So to do it with midpoint formula, we are going to find the midpoint of AC, which you would find, so actually I'm just going to write in the values here. So D is at 1, 0, C is at 2, 3, 4, 5, 6, -1, 7, 8, 2, and A 1, 2, 3, 3. So to find the midpoint of AC, we would do 3 plus 6 divided by 2, comma, 3 plus -1 divided by 2. And that's going to come out to 9 divided by 2 or 4.5, and 2 divided by 2 are 1. So 4.51. Then you find the midpoint of BD, and you show it. So you do 1 plus 8 divided by 2, comma, 0 plus 2 divided by 2. And that comes out to 9 divided by 2, or 4.5, and 2 divided by 2, which is 1. So since the midpoints are the same, so you would use actually the exact same reason that's written right above this problem in the book, but since the midpoints are the same there, justify your answer, we can say, so since the midpoints are the same, we can say that the diagonals bisect each other, and therefore it is a parallelogram, okay? So midpoints the same equals diagonals bisect, or it means that diagonals bisect each other, which means that you have a parallelogram. Okay, so that's how I did it on that one. The next way that I could do it, so midpoint formula, is I could use slope formula. So slope formula, you're trying to prove that your opposite sides are parallel. So if you do it with slope formula specifically, you would do the slope of, let's say, AB here, And you can count these, but you need to write them down. So down 1 over 1, 2, 3, 4, 5. So negative 1 over 5. The slope of BC would be up 1, 2, 3 over 2. So 3 over 2. The slope of DC would be 1, 1, 2, 3, 4, 5. So it's down 1 over 5. And the slope of AD is up 3 over 2, which is 3 over 2. So we have all of our slopes written, and then we can essentially say since the opposite slopes are the same, that implies that both pairs of opposite sides are parallel, which implies that you have a parallelogram. Not like super completely written out, but that's the idea of what you can do there. Lost my pen here for a second. There it is. Okay, and so then the last thing is that if you wanted to do it with distances, you can do it with distances to prove that opposite sides are congruent. So I'm not going to go through every distance here just because this one does take the longest, and most of the time we're not going to do it this way. But if I'm going to do the distance, I'm going to essentially find the distance of AB. And what I'm doing in that case is making that Pythagorean theorem. So there's a 1 and a 5, and I'm going to do 1 squared plus 5 squared equal to c squared, which means I'm going to do a square root. So I have 1 plus 25 or the square root of 26. Maybe I can't do these. These aren't that bad. And then BC is going to be the square root of, I have a 3 by 2 there. So 3 squared plus 2 squared. So 9 plus 4, which is 13. Let's just leave it as the square root there. DC, we look at the same thing here. We have the square root of, it's 1 by 5. So it's 1 squared plus 5 squared. And that's going to be that square root of 26. And then AD is this, and it is the square root of these. It's not 26, 13, and 26. Is up 3 and over 2. And so that's going to be the square root of 13. So what I've shown here is that opposite sides are congruent, which shows that we have that both pairs, let's move this up just a little bit. Oops, not that far. So we have both pairs of opposite sides congruent, which leads us to knowing that we have a parallelogram as well. So those are kind of all ways to prove that. I did them all pretty quickly, but that's kind of the idea behind it for these. Okay, so that's kind of where I'm going to leave you guys at for that one, and you have some homework to do.